has a data on element composition of the sun, the ion state, the plasma velocity, the particle energy, the magnetic field, and others. ስለዚህ ከኤሲኢ ከሚባለው ሳተላይት ሚሽን ብዙ ዴታዎች እናገኛለን። ስለዚህ በተለይ ስፔስ ዌዘር ላይ የምታጠኑ if you want to study the variability of space weather, you need to visit this Advanced Composition Explorer website so that you will get this data, okay? It was launched in August 1997 and it is still operating, and it has fuel to continue at this L1 until 2024. So it's on now the satellite is active and it's operating. It gives us information about plasma velocity that we get from the sun, the particle energy, the magnetic field, the composition, the ion state, and others. So it's one of the dedicated mission for studying the solar wind and coronal mass ejection. The other one, which all of you know, especially the astronomers, is the SAHO, cooperative project between European Space Agency and NASA, okay? European Space Agency and NASA. It is SAHO. So this is a spacecraft, and it's located at the same point, at Lagrange L1 point between the Earth and the Sun. It includes 12 instruments. The ACE was 9, now SAHO has 12 instruments. And it's dedicated for solar interior, solar atmosphere, extended corona, and particle. And it was launched in 1995 and still operating. SAHO ብዙ ጊዜ አስትሮኖሞች የኮሮና ማስ ኢጀክሽን ካታሎግ ለማግኘት ስለ ፀሐይ ሶላር ዊንድ ኢንቴሪየር ለማጥናት ሶላር አትሞስፌር ለማጥናት በአብዛኛው የሚጠቀሙበት የአውሮፓና የናሳ በመተባበር launch ያደረጉት spacecraft ነው ወይም satellite constellation, and therefore it is called SAHO. It's very important. You can see the satellite just from this slide. The SAHO has different instruments, as I've said. 12 instruments አሉት ብያለሁ። አንደኛው ለምሳሌ SAHO EUV imaging telescope ነው. Therefore SAHO has its own telescope and it images the sun at a wavelength of EUV range. Then it uses of multi-layer passbands. Therefore, one of the instrument is EUV imaging telescope, okay? And therefore, from this, we can get some measurements. You can visit that one. The other one is trace solar telescope. One of the instruments among these 12 embedded within the SAHO is trace solar telescope. It's also dedicated to take image, and then it traces the phenomena of the sun by using solar telescope as well. And the other one is EUV corona tracer image, and then this is also another instrument embedded with SAHO, and you can see different images, specifically the EUV that is associated with the coronal image can be obtained, and then you can see these different phenomena can be imaged using this EUV corona trace imager that's embedded with that. You see the pixel size of the image and other information can be obtained here. It gives the image of photosphere, chromosphere, and corona. Using this EUV corona trace imager of the SAHO, we can take an image of the photosphere and the chromosphere and the corona. Therefore, by using this, we can take images of different phenomena from different layer of the sun. That means, photosphere, chromosphere, and corona. Photosphere, chromosphere, and corona. From this, we can take the image using this instrument. The other instrument or mission dedicated for studying space observation is the Japanese Hinoid spacecraft. is operating in collaboration with United States and UK. It is a spacecraft and located at 800 kilometers from the Earth. Okay. Therefore, it includes a set of 3 instruments. So the Japan, UK and United States abro operate የሚያደርጉት አሁንም የፀሐይን different phenomena ለማጥናት የምንጠቀምበት መሳሪያ ሂኖይድ ስፔስክራፍት እንለዋለን። ይሄ ሂኖይድ ስፔክትራፍት 3 ፓርቶች ይዞ ይኖራሉ። 3 ኢንስትሩመንቶች አሉ። አንደኛው ኤስኦቲ ነው፣ ሶላር ኦፕቲካል ቴሌስኮፕ with a diameter of 0.5 meter. And the other one is EIS, that is EUV imaging spectrometer. And the third one is X-ray telescope imager, that is XRT. Therefore, 3 instruments are embedded with Japanese Hinoid spacecraft, which is located around 800 kilometers. It was launched in 2006. So you can see different instruments are embedded with that. Beside EIS, SOT, and XRT, we do have also interferometer, that is FFP is also there. And the other one is solar optical telescope. When we see some examples or images that has been taken by this Japanese setup, for example, this image was taken by SOT of the Japan setup. And then as you can see, this image is the black spot that is from the photosphere of the sun. It's called the sunspot, and the magnified scale of the sunspot is given in the right side. And therefore, not only the sunspot, the convective cells, the emerging magnetic flux that can be observed from the sun can be done using solar optical telescope. Therefore, Japan which operate in America, UK and US operate in America instrument, spacecraft no. የተለያዩ ኢንስትሩመንቶች አሉት ብለናል። አንደኛው ሶላር ኦፕቲካል ቴሌስኮፕ ነው። ኮንቬክቲቭ ሴሎችን፣ ማግኔቲክ ፍላክስ እንደገና ሰንስፖትን ኢሜጅ ማድረግ ይቻላል ማለት ነው። በእነዚህ እንደዚህ እንደምታዩት ብላክ ስፖቱ ይታያል፣ ማግኔቲክ ፍላክሱ ይታያል። የፀሐይ ኮንቬክቲቭ ሴሎቹን ከፎቶ ሴል ላይ ማየት ይቻላል። Not only this one, we can also have this kind of image from SOT again. And as you can see, it is an eruption of magnetic field, which we call specifically as prominences. And you can observe the dynamics of the prominences using the SOT. And therefore, this image can be considered. And then this instrument is also dedicated for studying the dynamics of the promise, beside that of the convection, the magnetic field, and the sunspot. The other one is polar coronal activity that can be obtained again with this setup, XRT and EIS jet observation. Therefore, the two beside that of SOT, we do have XRT and EIS jet observations, and therefore using this XRT, the Hinoid sees constant activity in the polar coronal holes, that is a coronal jet, and it was first observed in 1995, and therefore this kind of ejection from the corona can be observed using this arrangement. The coronal dynamics, you see, different dynamics from the corona can be obtained, and then at different observations you can see this kind of image using the Hinoid spectral imaging observation. Therefore, Japanese are also contributing for studying the solar observation or for taking the solar observation. The other one, which most of you know, is the Solar Terrestrial Relation Observatory. It's abbreviated as STEREO mission. Are you with me?
Yes, yes, Doc.
Okay, great. The other mission is a stereo mission. I think most of you have got this stereo mission website, and then try. I believe that you try to see the data that is associated with Solar Terrestrial Relation Observatory. So, two identical spacecraft leading and following the Earth. One is before the trajectory of the Earth, and the other is after the trajectory of the Earth. Therefore, ahead and behind spacecrafts are there. ሁለት ስፔስክራፍቶች ናቸው እዚህ ጋር ያሉት ስቴሪዮ ሚሽን ላይ ከመሬት ትራጀክተሪ በፊት እና ወደ ፀሐይ የቀረበና ከመሬት ትራጀክተሪ በኋላ ከፀሐይ ትንሽ ራቅ ያለ ሁለት ሳተላይቶች ወይም ሁለት spacecraft missions ናቸው አንድ ላይ stereo mission ተብሎ የሚጠሩት. It was launched in October 2006, and then specifically this stereo mission has 4 instruments. አራት ኢንስትሩመንቶች አሉት ወይም አራት ኢንስትሩመንት ፓኬጅ አሉት. በዋነኝነት ይሄ ሚሽን ላውንች የተደረገው with the goal of understanding the origin and the consequences of coronal mass ejection. ስለዚህ ስቴሪዮ ሚሽን ወይም ስቴሪዮ ኦብዘርቫቶሪ ላይ ስለ ኮሮናል ማስ ኢጀክሽን ዴታ እናገኛለን ማለት ነው። አላማው ይሄ ሚሽንም ሲደረግ የነበረው 2006 ላይ just it is to understand the origin and the consequence of the coronal mass ejection. For example, behind ያለው ከመሬት ትራጀክተሪ በኋላ ያለውን የሳተላይት ኦብዘርቫቶሪ ወይም ስቴሪዮ ኦብዘርቫቶሪ stereo B እንለዋለን። ከዛ በፊት ያለው stereo A ይባላል ማለት ነው። Okay, therefore two stereo missions are there, stereo A and stereo B. Stereo B refers to the behind the trajectory of the sun, the earth. Stereo A refers to before the trajectory of the earth. Therefore stereo A has identical instrument suite with that of B, and therefore A and B spacecraft. Okay, and these two spacecrafts are now 150 degree apart. እነዚህ ሁለቱ ስፔስክራፍቶች ኤ እና ቢ የምንላቸው የስቴሪዮ ሚሽንስ 150 ዲግሪ አፓርት ይለያያሉ። በማዕከላቸው ያለው ርቀት ነው። if you see this is the trajectory. As you can see here, the sun is there. Before the sun, the red circle or the red trajectory shows the stereo A trajectory, and then the green one shows the Earth's trajectory, and behind the green one we do have stereo B trajectory of stereo mission. So stereo mission orbits looks like this one. Again, the coronal mass ejection is going to be studied using that one. Using this stereo mission, as I've said, there are 4 instrument package: SECCHI, plastic, swaves, impact. እነዚህ አራቱ ኢንስትሩመንቶች ለተለያየ ሚሽን ልክ እንደ ስቴሪዮ የአንድ ሚሽን ፓርት ሆነው የተቀመጡ ናቸው። we can see, for example, SECCHI UV imager. That means it's an UV imager, so with a solar telescope አለው with different wavelengths, or in terms of angstrom. Such kind of image of the sun can be taken using this one. This SHI UV has 2 cores እና የላስኮ የሚባል ኮሮኖግራፊ ወይም የኮሮና ማስ ኢንጀክሽን ዲፍረንት ኢሜጆች የምታገኙበት ሴታፕ ነው። ኮሮኖግራፊክስ የምንለው ካታሎጉን ላስኮ ብለን ጠራዋለን። እዚህ ካታሎግ ውስጥ you can get a data of COR1 and a data of COR2. For example, using this COR1 we can measure the polarization, okay, and using COR2 we can get high spatial resolution and time resolution or time resolution of the coronal mass ejection. የኮሮና ማስ ኢንጀክሽን ካታሎግ የምናገኝበት stereo mission ነው። ከዚህ ላይ ለምሳሌ if you want to say something about the behavior or the characteristics or event description of the storm, that storm can be associated with coronal mass ejection. So you can say something about how the corona was involved by taking different images from this catalog. You can say something, the evolution of the corona before the happening of the storm, so that coronal image will be very, very supportive for your storm event description. ስለዚህ ብዙ ጊዜ ምንድነው የምናደርገው? ለምሳሌ March 17, 2015, there was a very huge magnetic storm or geomagnetic storm, and the storm index was about minus 223 nanotesla, which is totally extreme event. It was extreme event, and therefore ያንን March 17 storm eventun ለመግለጽ ብዙ ጊዜ scholars they use coronal mass ejection images. March 17 ከመድረሱ በፊት ከማርች 14 ጀምሮ ያሉትን ኢሜጆች ወይንም በማርች 17 ከመጀመሪያው 0 ዩኒቨርሳል ታይም ጀምሮ ያለውን ኢሜጅ እየወሰዱ they will tell us something about how the event was characterized and associated with the coronal mass ejection. By the way, the storm can be associated with the coronal mass ejection as well as co-rotating interaction. And therefore, based on the DSCT, we can identify whether the storm is associated with a coronal mass ejection or co-rotating interaction. And then this type of catalog is very important in identifying our space weather events. Space weather eventaችን ስናጠና ብዙ ጊዜ እነዚህን ኢሜጆች እንጠቀማለን። ስለዚህ ስለ ሪዛልት ለምሳሌ what has happened due to this storm on our GPS observation ወይንም ሬዳራችን ላይ ወይንም ሌሎች ኦብዘርቬሽኖች ላይ ምን ተፈጠረ ከማለታችን በፊት basically we should explicitly state the event. We should explicitly describe the storm event, and one of the supporting mechanisms to describe the event is by taking the coronal image, coronal mass ejection imageዎችን በመውሰድ እነዚህ already freely you can get freely from the stereo emission catalog or from LASCO catalog. የየቀኑን በቀን ውስጥ በየሰዓቱ ያሉትን ኢሜጆች ማግኘት ትችላላችሁ። በጣም freely available ናቸው። እነዛን በመጠቀም ለምሳሌ you can check how the coronal mass ejection was involved during March 17, 2015. ሁላችሁም ይሄንን ቼክ ማድረግ ትችላላችሁ። ከዛ በኋላ ኮሮናው እንዴት ኢንጀክሽኑ እንዴት ኢንቮልቭ አደረገ የሚለውን ነው ካየን በኋላ እንደገና ሶላር ዊንድ parameters like the solar wind speed, the IMF, BZ, and the solar wind the solar wind density, the solar wind pressure. እነዚህን ፕሎት አድርገን ከኮሮና ማስ ኢንጀክሽን ኢሜጅ ጋር ሪሌት አድርገን ስቶርሙ ምን አይነት ኢቨንት እንደነበረው ምን እንደሚመስል ማስረዳት ይቻላል። This kind of description is very important when we write scientific papers in space weather or in characterizing or the variability of our ionosphere, the upper atmosphere. So this is one of the mission. As I said, this is stereo. The other instrument is the NASA Solar Dynamic Observatory, SDO. Besides the stereo and other SAHO and others, NASA has also designed Solar Dynamics Observatory, SDO, Solar Dynamic Observatory. You can see the image of the satellite that is dedicated for this mission. SDO is the first mission to provide full sun imaging both above and below the sun surface. ለመጀመሪያ ጊዜ full image የፀሐይን ከፀሐይ በታችና በላይ ያለውን አጠቃላይ ሰርፌስ ፓርቷን በደንብ ኢሜጅ አድርጎ የሰጠ የሳተላይት ሚሽን ነው። it is called the SADO እንለዋለን። It includes a set of 3 instruments. ሶስት ኢንስትሩመንቶች አሉት። High resolution imager for precision measurements and vector magnetograms. By the magnetograms are a sensor for the magnetic field. And the other instrument is atmospheric imaging array. It uses 4 high-speed UV images of the corona. And the other one is extreme ultraviolet variability experiment. Therefore, እነዚህ ሶስቱ experimental setups በሻዶው ላይ embedded ሆኖ ያሉ ናቸው። እነዚህ ሚሽን ይዞ ነው ማለት ነው የሳተላይት ላውንች የተደረገው። The satellite, this shadow launched in February 2010 and is designed to operate for 10 years. And then all instruments are fully operational. It generates 2 terabytes per day of data from its main instrument. Therefore, this kind of mission is being operated by NASA. ለምሳሌ shadow ከላካቸው ኢሜጆች መካከል recent image from the shadow. Okay, you can see 4 dual channel telescope of similar design to obtain images of photosphere, chromosphere and corona. Corona, photosphere, chromosphere, and then corona, photosphere, chromosphere image was set in Malet. It's not for the sake of luxurious or for the sake of just looking at the image. Instead, for the sake of studying the variabilities in terms of magnetic variability, particle variability, as well as radiation. እነዚህ ኢሜጆች የተለያዩ ፌኖሜና ነው የሚያሳዩን። magnetic ለምሳሌ ፕሮሚስ ፌኖሜና ሊሆን ይችላል፣ ፍሌር ሊሆን ይችላል, and the other phenomena can be obtained. And for filament, for example. Therefore, this kind of image can be obtained using different missions. The other mission is solar orbiter. It's a mission to the inner halosphere. You know, the halosphere is a region between the sun and the earth. ከፀሐይ እስከ መሬት ያለውን አጠቃላይ ሄሎስፌር ነው የምንለው። ከማግኔቶስፌር እና እስከ ሰን ያለውን ጂኦስፔስ ኢንቫይሮንመንት እንለዋለን። በፀሐይና በማግኔቶስፌር መካከል ኢንተርፕላኔተሪ ስፔስ አለ። ከዛ ፀሐይ አለ። አጠቃላይ ከፀሐይ እስከ መሬት ያለውን we call as halosphere. And then there are different missions for helospheric studies. Specifically, the one dedicated for the inner halosphere is the solar orbiter. The solar orbiter. It's a NASA and European Space Agency mission and was launched in 2017. And then it carries remote sensing and in situ instruments. The remote sensing has visible imager and magnetograph, UV imager, UV spectrometer, coronagraph, hemispheric imager, X-ray imager. የተለያዩ ኢሜጆችን ልንወስድ የምንችል ለምሳሌ UV ስፔክትረም ላይ ኤክስሬይ ስፔክትረም ላይ አጠቃላይ የሄሎስፌሪክ ኢሜጅ ለመውሰድ የሚያገለግለን ሪሞት ሴንሲንግ መጠቀም ይቻላል። እዛው ኦሪጂናል ሎኬሽኑ ላይ ሆነን ደግሞ ኢንስቲው ኦብዘርቬሽን መውሰድ ይቻላል። ለምሳሌ ኢነርጄቲክ ፓርቲክል ዲቴክተር፣ ማግኔቶሜትር ፎር the magnet, radio and plasma wave detector, solar wind analyzer. Therefore, the solar orbiter is dedicated for this instrument. You see how the different organizations, including ESA and NASA, are operating different missions to study the sun or specifically the halosphere. And then here you have to know that how it is important studying the halosphere. This is because the thing that happened on the sun has an effect on the earth, and therefore for having forecasting, nowcasting, or the warning or modeling and others, we need to study this halosphere. Specifically, the sun should be studied. The sun should be studied. The other mission is the Solar Pro Plus. It's a NASA Solar Encounter mission. It was launched 2015, okay, and remains in ecliptic plane, no forward viewing solar instruments, emphasis in situ observation, sample plasma and dust in the outer corona. ይሄኛው ለምሳሌ outer corona ላይ ያለውን ፕላዝማ እና dust particle sample የሚያደርግ ሚሽን ነው። እንግዲህ የተለያዩ ኢንስትሩመንት አሉ። ከዛ ውስጥ fast ion and electron analyzer, ion composition analyzer, energetic particle instrument, magnetometer, plasma wave instrument, neutron or gamma ray spectrum, coronal dust detector. These kind of instruments are embedded with this mission. በነገራችን ላይ እነዚህን ማወቅ ወይም ሪቪው ማድረግ ያስፈልገበት ምክንያት when you write a scientific paper in ionospheric or helospheric study ሜቶዶሎጂያችሁ ላይ ለምሳሌ ሶላር ዊንድ ወሰድኩኝ እንደዚህ ያሉ IMF ዳታ ተጠቀምኩ ሲባል ከየትኛው ሳተላይት ኦብዘርቭ እንደተደረገ ከየትኛው ሚሽን ላይ እንደተደረገ methodology ላይ በደንብ መገለጽ ስላለበት ነው ማለት okay you may get directed from the website but you need to say something about those missions dedicated for such observations ከኔ ጋር ናችሁ ልጆች okay so እነዚህን ኢንስትሩመንቶች ማወቅ ያለብን ምክንያቱም ሳይንቲፊክ ፔፐር ላይ ሜቶዶሎጂ ስንጽፍ ዴታው ከየት እንደተገኘ መጻፍ አለብን በአብዛኛው ምናረጋው ከዚህ ዌብሳይት ወሰድኩ ከዚህ ነው ምንለው ግን ለሰን ኦብዘርቬሽን ወይም ለሶላር ኦብዘርቬሽን ዴዲኬትድ የሆኑ ሚሽኖችን መጥቀስ መቻል አለብን ማለት ኦኬ ለምሳሌ ከሶላር ፕሮ ፕላስ ከሆነ የወሰዳችሁት ዳታውን ሶላር ዊንድ ስፒድ አዮን ሶላር ዊንድ ion composition when እነዚህ አይነት ፓራሜትሮች ተጠቅማችሁ ከየት እንደሆነ ስፔሲፊካሊ ስለ ኢንስትሩመንቱ ማውራት መቻል አለባችሁ and therefore this is the reason why I'm focusing on that. The other one is again another Japanese setup, the Japanese Solar C2 mission concept which is under study here and then they do have their own plan A and plan B there and therefore they need to observe different things. One is the magnetic field, X-ray, optical helioseismic observations, and they want to emphasize studies at high solar latitude. They try to investigate meridian flow and magnetic structure inside the sun to the convection zone base. And they do have also Plan B, which is dedicated for high spatial resolution, emphasis at photosphere to coronal connection, the photosphere and the coronal connection ለማጥናት ሚሽን አርገው ያጠኑት ያሉት ነው ሚሽን ነው launched የተደረገው in 2016 ነው and way different organizations are working with this Japanese setup. Having said this mission, let's have some point again on the sun and the earth's connection. So ይሄን ካለን እነዚህ ሁሉ ጥናቶች እነዚህ ሁሉ ሚሽኖች አሁን ያየናቸው ሚሽኖች የፀሐይና የመሬት ኢንተራክሽንን ለማጥናት የምንጠቀምባቸው የሚሽኖች ናቸው so the reason why we need to know this is because we need to investigate the interaction or the connection between the sun and the earth. Okay, what happened on the sun affects our technology, and then basically the space as well as ground-based technologies can be affected by the phenomena that happen on the sun. And then to observe the sun, the different organizations are operating different missions, specifically dominantly the NASA and ESA are operating different satellite missions. There are some attempts at African level, like South Africa and other developed African countries are trying to operate their own satellite mission, which are dedicated for sun observation. But since these data are freely available, for the sake of currently we don't need to worry about our satellite. Instead we can appropriately analyze the behavior of the sun or the activity of the sun using the different missions mentioned above. Okay, therefore now let's come to the sun earth connection. Once again When you talk about the sun-earth connection, we need to start from the sun, because the source of this space weather, or the source of radiation, the source of magnetic field, the source of particle is the sun. Then in between the sun and the earth, we have